everyone. In today's lecture series of Automata Theory and Compiler Design, we are going to see about that introduction to the bottom-up parser and types of bottom-up parser and how to parse the input string using the shift-reduce parser and LR parser. So already you know that what is a parser. The parser checks the given input statement whether that statement is as per the syntax of the programming language correct or not. The function of parser is get the stream of tokens from the lexical analyzer and produces the parse tree as an output. In that parser you have a top down and bottom up parser. In the last video we saw about that what is a top down parser and how that works. In today's we are going to see about that what is a bottom up parsing. So bottom up parsing is nothing but our input string is reduction into the start symbol using that parse tree construction. In the parse tree it is the terminals are the leaf nodes and non-terminals are the interior nodes. So in that, for example, consider this example, you have a production like S tends to small a, capital A and capital B comma small a. Then again the small a have the again two productions and B have a production of tends to D. So from that production rules we are going to derive the input string ABBC DE means first start with the ABBC and that string is reduction into the start symbol using the right sentential form of rightmost derivation. So this is the way that the bottom up parsing is work. The types of bottom up parsing is that it is a non-recursive shift reduce parser and operator precedence parser. So the non-recursive shift reduce parser is called as an LR parser. The LR parser we have another, it is classified as a 4 types. One is an LR of 0, then SLR, that is a simple LR parser. Next one is an look ahead LR parser and canonical LR parser. So based upon that specifications, LR of 0 is less powerful and CLR and LALR is more powerful. So based on that LR of 0, SLR, only these parser are differ in terms of the parsing table construction and also the input string parsing. So what is the LR of K? So LR of K, the first L stands for left to right. We are going to parsing the input string and scanning the input string from left to right. Then second R implies that it is using the rightmost derivations. Then next K isn't it is a look ahead. So more than based upon the types of parser we can use the single or more than one input strings are used to parse the input string. So this is the specification and definition of LR of K parser. So in that first mainly the LR parser works based upon the shift reduce parsing. So the shift reduce parsing is type of the bottom up parsing. So that that produces the parse tree and we are going to parsing the input string using the stack construction. For example, in the shift reduce parsing mainly 4 actions is done. One is a shift, other one is a reduce, other one is an accept, and finally we have an error. Considered for the grammar, we have a grammar. The previous example also we saw that same example. So in that we are going to reduce the we are going to get the start symbol from the input symbols A, B, B, C and D. So it is based upon the rightmost sentential form derivation that is going to reduced. Okay, so that is a shift reduce parsing. So in that we are using the two terms. One is a handles and handle pruning. So in the right side we have a production. So that every right side production, every input string is replaced by the non-terminal and finally we get the start symbol. So that input string, so that based upon that production rules, the corresponding input string is reduced into the left hand side non-terminal. So that input string reduced into the left hand side non-terminal, it is called as a handle. So based upon the handles only we are going to reduce that right side production into the left side non-terminals. So that process is called as a handle pruning. So we are going to reduce the bottom top of the handle into the corresponding non-terminal. That process is called as a handle pruning. So this is a stack implementation of the shift reduce parsing. For example, consider the input symbol id plus id star id. So that input symbol is reduced based into the starting symbol of e using the set of protection rules. So the stack implementation of shift reduce parsing, we have a stack, input and action. So in the stacks, the starting the stack contains, we have a dollar symbol, and top of the dollar symbol we have a starting symbol. In the input buffer contains the input string followed by the dollar symbol. First we look at it. So what is the starting top of the stack and input symbol, first symbol. So if there is any e tends to, we have an e and id, so there is a corresponding term is reduced, so the id is shifted first. So once you have a, there is any reduction, means that reduction is that non-terminal is replaced by the corresponding id. So in the stack implementation of shift reduce parsing, whether there is a we are doing the shift operation, once that input string is shifted onto the stack, so there is a corresponding protection for the corresponding non-terminal, means that is reduced. So finally we have an accept. When we have the accept, means the stack contains a dollar and start symbol, and input buffer contains a dollar, means we reach the accept state. So this is these things are entered into the parsing table. So we have in the parsing table, we have a shift and reduce and accept function. So the remaining entries are called as an error function. This is the way the shift reduce parsing is implemented using the stack. So next is an this is the basic concept behind all the LR parser. Now we will see what is the model of LR parser. So in the LR parser, we have a LR parsing program. That LR parsing program construct the stack and input buffer and also the parsing table entries. It checks whether the given input is correct or not. If it is correct, it produces an output as a parse tree. Otherwise, it reports an error. So for that model of LR parser, we have a input buffer, stack, and also the parsing table. So the stack we have a top of the stack is compared with the input buffer first symbol. If there is any if the input symbol contains that input string is shift, that shifted input string have any reduced non-terminal, means that is replaced. So finally we get the stack contains the starting symbol and the input buffer contains the empty, means we are accepting the input string. So this is the way all the LR parsing methodology is done. Only differ, we have 4 types of LR parser. The difference based upon only the parsing table construction and input string parsing only. I hope you will understand what is the bottom-up parser is doing, and also the types of parser, and how we will do the shift reduce parsing using the stack implementation, and model of and architecture of an LR parser. Thank you.